Hello everyone and welcome to Pyanodons mods. This is Otaku Showboat, and in this tutorial I'll be going over the lead processing chain. As usual, don't forget to comment, like, subscribe, and hit the notification bell to help make this tutorial series visible higher up in search results. You can follow me on Twitch at twitch.tv/otakushowboat, Twitter at otakushowboat, and visit my website at otakushowboat.com. You can help support my continued existence and help to accelerate the production of these tutorials by becoming a patron on Patreon at patreon.com/otakushowboat. You can also help support Pyanodon and further mod development by becoming a patron at patreon.com/Pyanodon. As a disclaimer, Pyanodon's mods are in a constant state of flux, so any numbers I present may change, and some other aspects of the actual chains may change at any point in time. The mods for this particular save file are nearly identical to my stream save for my initial Pyanodons playthrough on stream, the list of which is linked below this video on my website's stream schedule page. The only difference is that I am using the Infinity mod to help to showcase this particular overview as well as all of the other ore processing chains. So with that said, let us get started. Okay, the lead chain. This is actually lead and silver, for reference. So lead and chromium have additional alloys / additional plates that they can make outside of just lead or just chromium. They lead into silver and gold. Lead, though, is very tied with its silver output. There is no separate chain for silver processing from lead. There is a separate chain in chromium, which makes it a little bit easier to handle if you have too much of one or the other. You can void out what you don't need there. But here, you'll end up in very interesting circumstances of having to void one or the other, depending on what you need at the time. So, it's a very simple chain. Lead, as with titanium, will require acetylene to mine, which means that you are not going to be accessing lead until after you pick up at least coal processing 1 as a technology, so you will likely not ever be doing a stone furnace setup for lead. You will be going directly into advanced foundries from ore, in which case the hot air recipe is significantly better. It is a 3x improvement over the standard recipe. I do not know if this is exactly intended, but it is a thing that currently exists. Again, everything is in a constant state of flux and may change at any time. Just, this is how it is right now, as of this recording. Either way, no matter what, even if this gets nerfed a lot, down to 50% bonus, as with everything else, it's still worth doing. Beyond worth doing. So once you've set this up, you need lead initially for some tanks, some storage tanks. You'll also need it if you're using biters to make some firearms for automating your magazines and automating your piercing rounds, as well as for shotgun shells, excuse me. You need it for powerhouses. This may be the first real time you need it. If you are interested in doing combustion mixture power relatively early, you will need lead for that. It's used in various other things, but in particular it is used for all of these fluid tanks. Actually, the one with the most utility, I think, is actually the 3000L tank. The 4000L is convenient in that it has inputs and outputs, one on each side, on all 4 sides, and is a square. The 3000L tank is more of an inline tank, you can think of it as, and that makes it very nifty to place anywhere. Outside of that, Mark II stuff and beyond, some Mark I stuff in here. Tar extractors, very important. This would be a reason to do chromium as well as lead if you're trying to do tar extraction in the early game. Other than that, it's necessary for a few other recipes if you need propane early, or if you want propane early. Of course, solder, it is a necessary ingredient for solder, and you use a lot of solder throughout the game, but that'll come a little bit later. Going down the actual line, once you decide that you want to start doing the actual chain, at Red Science, you get access to G1, with a 50% chance of giving you G2, with nothing that you can do yet at G for that G2. So you are either going to be stockpiling it, which I suggest, or you're going to completely skip the Red Science step of this chain and only set this up at Green Science, where you can actually have something to do with your G2 lead. Because it really isn't worth doing the Red Science. Remember, again, that is in the current state of this mod, and this may change after Pyanodon watches this, unless it is actually intended for it to be this way. But as of right now, there is no way to deal with the G2 lead. Do not be surprised if at some point in the future, if you watch this video, that you can end up doing the processing of the G2. But just bearing that in mind. So, skip red. Skip red is basically what I'm saying. At this point in time, at lead processing 2, that's when you can process your G2 back into G1. This recipe is what I think should be back here at lead processing 1, but I digress. The recipe here, oh no, I take that back. This recipe is your G1 into G2. So if this was G2 to G1, that would make sense. But actually, no. Because this is G1 into 2, you're trying to get 2 and then converting your 2 into 3, and then processing into dust to make molten. That is what will be very interesting. And this is when we'll get access to silver, is at Green Science as well. So, Red Science, probably don't bother, and then Green Science goes all the way up to dust here, and we're only using screeners, impact crushers, and secondary crushers, and this is your entirety of your chain at Green Science, and then the dust will convert into your molten lead and your silver plates. At Blue Science, you go all the way up to high grade, and from here, there are some steps along the way, like at, I believe it is Refined Dust 3, you can get to a molten silver only recipe from Refined Dust 3, so you do have the option of converting your lead directly into exclusively silver, but that is in no way even remotely close to efficient. I do believe that you can get way more silver by going all the way down the line and having both high-grade lead and silver. Now, at dust, it's very easy to control your production of silver and lead, because it's ultimately just choosing what to do with your dust. Either you will make silver, or you will make lead, or you will do both. And if you back up on one, you don't necessarily back up on the other. At Blue Science, converting your dust into Pulp 1 and refined dust, and then converting the refined dust through a few steps into the Pulp 1, and then converting that into solutions, then into concentrate, then into high-grade lead and silver, you don't have that much control anymore. You get equal amounts of high-grade lead and silver. So if you, for instance, back up on lead, well, you've now choked your silver production. Now, as I had said, there is a way at Refined Dust 3 to convert directly into silver, but what I would prefer to do is void out the excess high-grade lead. You are generally speaking going to have a massive overproduction of lead versus silver that you need at this tech level. I mean, just in general anyway, I think you're going to be overproducing on lead because it isn't majorly used as like a huge demand overall. Lead is like 10 acetylene per mining cycle to mine, which is really huge amounts of acetylene in the early game. But by blue science, which you have blue science at this point in the game, this becomes a lot more viable. This was actually the very first ore processing chain that I set up through high grade in my stream playthrough, because overall this is actually a pretty simple process, especially in comparison to the previous tutorial, which was the titanium chain. This has way less steps. Overall, there's not really any geometric series to worry about in here. We've seen pretty much all of this before in terms of the outside inputs at the blue science phase, and it's really simple here. You get your pulp 1 from your dust, and you get refined dust that converts into dust 2 to dust 3 into pulp 1, and then that goes into pulp 2 into a solution, into solution 2 and 3 into 3 into concentrate, and then the concentrate into high grade. Now, the high grade of each of these can be reduced and centered. I don't have a repair pack. Hey, give me reps. Anyway. So that is the overview of the chain. I have decided to not include the extra, like, plate molten stuff down here, because that is pretty self-explanatory as we go along here of my suggestions for what to use. So, as I had said, at pre-science, you will, or at red but don't want to set up the remaining chain yet, you will be doing this recipe, converting your lead into lead plates. It's 7.5 at 15 flat in, which is a yellow belt. Chances are you are not going to be having a yellow belt in at this point in the game, but if you do somehow manage to get all of that acetylene, a lot of acetylene per second to fuel it, then sure, go right ahead, make your 7.5 plates, but know that you're going to not really need 7.5 plates this early in the game anyway. You're going to be perpetually backed up on lead. Pretty much no matter what, you're going to be perpetually backed up on lead. And in fact, you're probably not even going to set up your green science processing of lead until you need silver. And you will need silver going into blue science and into circuit 2s. So you will need some amount of silver at green going into blue, but you won't do red. You won't do red because you end up with G2 that you don't have anything to do with yet, that you can't deal with yet. So skip red. Skip red. It converts. You'll have to deal with the stone when you do set up the processing of 1 into 2 here at green science. You will have to deal with stone. And that is actually about it. I don't think there's a gravel output on this particular chain, but there is a stone that you have to deal with. This does feed back G1, so this does have a geometric series right here I know I had just said that there aren't really any geometric series here. This one does feed back G1. I don't think I noted that. Yeah, I need to note that. The G2 to 3 also gives plus G1. So we're going to make note of that right now. So G2 to G3 plus 1, little geometric series here. That seemed to have eluded me when I was doing my text plates a little bit ago. Yesterday, actually. Or day before, I forget. This gets secondary crushed into your dust, and then as I had mentioned, the dust is versatile. It is used both in the molten recipe, which our molten is using borax and graphite on this particular chain. It goes into molten lead as well as into directly silver plates, and there is a hot air recipe for this. You're not going to get a lot of silver, but you're not going to need a lot of silver, and you will be getting a fair amount of lead plates out of this overall. Now, at blue science, when you start making your pulp and your dusts, here your refined dusts, note that the pulp is called silver lead zinc pulp. It doesn't ultimately matter what the name of the thing is, but it's pulp 1. It's pulp 01. And you need cyanic acid in. Now, at this point in the game, you already know how to get cyanic. It is just the recipe in the DDC for urea that makes cyanic and ammonia in equal numbers. You will get access to a specific recipe to make exclusively cyanic. I don't really enjoy that recipe very much, but that is also another option to you. So, cyanic in, and then simple ball crusher 1-to-1, and then 1-to-1 here to go from 2 to 3. You will have to deal with a sand byproduct right here. And then into pulp 1, this is where we're going to get a little bit more interesting. Into pulp 1 from your lead refined dust 3. Remember, lead refined dust 3 has this recipe to make molten silver directly. You can make molten silver directly here out of refined dust 3. Would not recommend it. Would recommend going all the way up the chain to your high grade and then processing your high grade into molten silver from there. Otherwise, just don't bother stopping here. It's better to void a high grade lead excess that you have rather than have your ore going directly into some silver, smaller amounts of silver, without any lead whatsoever. At this step, we've got our good friend the oleochemicals and Z3 reagent, or Z3 reagent, as well as some pressured air. Z3 reagent, we have seen this before. Oh yeah, we have seen this before. Z30 Reagent is also... Or have we seen this before? We have not seen this before. I take that back. We have not seen Z3 Reagent before. This is the one and only time in the recipes here. Interesting, you go from pulp 2 to solution 1. Right. Pulp 2 to solution 1. And dust 3 into solution 1. Yeah, that's right. It's yeah, pulp 2 to solution 1. Ah, this is wrong. I was wrong, folks. I was wrong, and someone probably already pointed that out. This is solution 1, not pulp 1. So yeah, let's go fix that. So yeah, this is not pulp 1, this is solution 1. I have made a note in my tutorial. Can't get everything right all the time, especially when trying to make these at a little bit faster of a cadence than usual. So this goes into solution 1. Then we have to deal with the actual pulp one afterwards. But so Z30 reagent, Z3. This stuff is phosphorus acid, carbonyl sulfide, and methanol. Now, I haven't really discussed how to get any of these right now. Phosphorus acid I will cover in the phosphate rock chain, which will come after I do my videos to make green science. It'll come in that period between green science and circuit 2s, because that's when you'll start doing your phosphate rock processing. But phosphorus acid is the very first product out of your crushed phosphate rocks. They convert into phosphorus acid, and then that is what is used to make your phosphine gas and phosphoric acid. But this would probably be one of the only times, or one of the first times, that you really are going to think about using the phosphorus acid as is. Carbonyl sulfide by Blue Science at this point in the game, you already have production of carbonyl sulfide, which you need for rayon for batteries, for reference. That it's used for rayon, so I don't really have to cover how you're going to get that. I plan on making a video specifically for rayon, I think. Yeah, I'll have a specific tutorial for rayon, and that will include carbonyl sulfide. And then methanol, I've stated before that I do enjoy the recipe that gives you methanol and syngas. There is a recipe in the gasifier that gives you methanol and syngas for organic matter and nexilate. I am a fan of this recipe because organic matter is just a localized log setup, logs into organic matter, and then the only issue with this is that this is not an insignificant amount of nexilate. The footprint to provide enough nexilate for this would be rather huge, depending on how far you're going on a nexilate processing chain. So bearing that in mind, that the nexilate plate count is actually pretty big, I'm not as much of a fan of this recipe anymore. This was a way of getting refined syngas, but there are various recipes for methanol. There is, of course, the idea of using copper and zinc and syngas to get methanol. There is the idea of using some chromium and oleochemicals, or perhaps I would do the methane with tin chromium. That actually gives you a reason to make tin chromium alloy, or in the alternative, a copper and titanium tetrachloride plate plus methane and hot air into methanol. This is a pretty good recipe overall, if you're willing to spend the copper plates and the titanium tetrachloride. If you're willing to do this, especially since copper plates you can ground bore for lubricant and coal gas, the overall footprint for that is pretty small in comparison to the ground boring for titanium, for instance, and the footprint you need to make the chlorine to make your titanium tetrachloride. And then methane is as simple as, if you're willing to have the footprint, a bunch of moon-drop greenhouses. But there are other ways of making methane. I actually think I like this, nickel and syngas, but it depends, because you can get nickel out of tailings. or crude oil, or whatever the heck it is. I think it's tailings, rather than ground boring it. And you can get methane directly out of tholins if you really were so desperate. But moondrop greenhouses, that's the, like, real way of doing it. You can do... There is a carbon dioxide plus water recipe. This is probably the way that you'll do this. It doubles the output of your moondrop greenhouses. Would not suggest doing the fertilizer, spending fertilizer on methane. But anyway, that would be your path to methanol, bearing in mind that there are other higher output recipes that involve molybdenum and vanadium. I would never suggest doing these. Like, only if you're doing particle acceleration for these and have setups to do these in perpetuity, would I suggest even remotely thinking about doing these methanol recipes here with the moly and the vanadium. Only if you have the infrastructure to support infinite moly and vanadium for it. Otherwise, just do this one in general, and that can feed your Z3 or your Z3 reagent. To turn your refined dust into solution 1. Now, dealing with the pulp 1 into pulp 2, we'll need soda ash regeneration solution. We've pretty much covered this before. This is basically like ash and tailings or something like that. Soda ash, it's ash and saline. Excuse me, it is ash and saline and water to make soda ash regeneration solution. I think I was thinking of the coal water slurry fuel, which is just like tailings. But yeah, soda ash, and saline. I've explained in previous tutorials how to get however much saline you ever desired out of some mushrooms. So give those a look. The solution, the pulp 2 into solution 1, we'll need more of the Z3 reagent and some pressured air. Now, the solution 1 into 2 and 3 is going to need lime. Now, lime is just coke plus limestone, so that should be easy enough by this point in the game. You should have plenty, or at least the ability to make plenty of it. The solution 2 converts into more solution 3 by adding water. So that's a pretty simple step. Just place the buildings. And then you will filter your solution 3 into your concentrate, your silver lead concentrate with filtration media. And from there, it's just one more step. Just solid separate. No outside inputs for your high grade. It's just solid separate your silver lead concentrate. There's no reason to stop sooner than this. Wink, wink, nudge, nudge. No reason to stop sooner than that. And yeah, your high grade silver can go into molten, and your high grade lead can go into a little more molten. And yeah, you're going to end up with quite a bit of both, and I would suggest to void the excess. You do end up with about this much, on the silver for, I think, 1 yellow belt worth of your lead in at Blue Science. It's not a ton, but it is a lot. And then this ends up being like 20-ish per second overall. It's like 20 of the lead and 5 of the silver. Around, like, give or take. Just rough approximations there. And that is your Blue Science. So really the only thing you have to make for this is your soda ash, which is ash and saline and water, and oleochemicals, which I've said before is lard plus nichrome plus water to make oleochemicals. And then your Z30 reagent, which is phosphorus acid coming from your phosphate rock processing chain. Note at this point at Blue Science, you cannot get an infinite supply of phosphoric rocks to make phosphorus acid, so you will have to mine them the old-fashioned way. Ye old-fashioned way of mining for these rocks. Unless you're on C block and have alternative methods of getting your phosphate rocks to make phosphorus acid. Carbonyl sulfide, you've done in rayon, and I'll cover with rayon. Phosphorus acid, I'll cover with the phosphate chain. And then methanol, which has lots and lots of ways of getting. Perhaps the titanium tetrachloride would be the easiest route for methanol at this point in time. The easiest in terms of overall setups, but in terms of what you already have versus what you would have to set up fresh each time. If you'd like to do local-based Nextlit, 5 per second local-based Nextlit, to feed this massive machine, as well as do the local 10 per second on the organic matter and void out or somehow use the other 100 per second that you'll be getting on the syngas, then go right ahead and do that. Make your 5 per second Nextlit on site and out of tailings, out of tar, making saline, by the way. Hey, you're going to need saline anyway for the soda ash regeneration solution, so you can do mushrooms. You can do your mushrooms into coal, destructive distillation column the coal into coal gas and tar and coke, convert the coke into a little bit more of that with ash as the output, void out your iron oxide that is produced as a byproduct of all of that with burners, and you can actually take the ash from that, all of that, combine all the ash together, take the tar, void out the coal gas, or convert it into more syngas and send that out and about, or use the coal gas as is. Take the tar and throw it into the saline water quenching tower recipe that will give you saline water plus flue gas plus tailings that can feed the Nextlit, and that can feed the saline water, and the flue gas converts into ash that can feed the soda ash regeneration solution. So then you have your tailings for your Nextlit for your methanol plus syngas. It's not going to be quite enough, though. You'll need to have enough to process the tailings into your 5 per second on Nextlit plates. So you might want to consider going relatively far up a Nextlit chain there, which that opens up its own can of worms, and we'll talk about the Nextlit chain in another tutorial after covering green science. So you can decide what exactly you want to do there, do your local organic matter, and then you'll be good. You'll have your Z3 reagent, or you'll have your methanol for your Z3 reagent. Just do what you did for carbonyl sulfide and pipe in your phosphorus acid from wherever you're doing your phosphate rock processing, and you're good. And you're good. You can go all the way up to high grade really easily, and then at Yellow Science, it is exactly the same as we have seen in many of the other ore processing chains thus far. Sodium sulfate plus diesel plus pressured air in to make reduced, and then a fuel source plus lime plus syngas plus pressured air to make sintered. It is always going to be 1 high grade to 1 reduced to 2 sintered. That is always going to be the case when you do reduction into sintering. And you do it twice, once for processing the lead and once for processing the silver. But chances are, even at Yellow Science, you might not necessarily need to do this. You'll probably do this to get more silver. You might not need to do this, but you might want to do it anyway. Depends on how much lead you are consuming by that point in the game. I have yet to actually play to this point in the game to have a good idea as to the resource demands for some of these products like lead. But what I do know from the grapevine is that when we cover the chromium processing, which will be the next tutorial, you actually overproduce gold now versus your chromium demand. But there are other ways of getting chromium that does not result in gold, which are good ways of supplementing your chromium production for you, so you could actually focus on gold and get your chromium in another way and get the excess chromium that you need by other means. And that will be a very interesting discussion that we will cover next time. Now, lead, molten lead, has no alloys. Molten lead has no alloys. As for the molten silver, silver plates is the only thing that makes. So we're not really dealing with alloys. But silver plates, though, has a silver zinc alloy. So Pyanodon, note for you, most of the other alloys in the game have a molten recipe. This one's missing. So expect to see eventually that there will be a silver zinc alloy molten recipe using molten silver and molten zinc. So for now, as of this recording, there is silver zinc alloy by adding refined syngas to silver plates and zinc plates. This is going to be used for, oh hey, look, it's vanadium from tar without having to do your particle accelerator recipe. It is a lot of tar. It is 1,000 tar per second to get a quarter per second of one unit. A quarter of one, like 0.25 vanadium per second. It's a lot of stuff. So yeah, it's better to just do the particle accelerator recipe. Wink, wink, nudge, nudge. You need silver zinc alloy for destructive distillation columns 4. Silver foam, superconductors. Superconductors are used in Mark III stuff mostly, and some space science stuff, and intelligent units, which is the circuit 4s, and then these guys are the superconductor servo mechanisms, are used in Mark IV stuff largely, and your high-tech stuff. So you will need silver zinc alloy for your late game bots and your Mark IIIs and your Mark IVs overall. Now, silver foam is used in helium, which has its place even outside of fusion energy stuff. And then biopolymers. Biopolymers, again, Mark III stuff, again. So we've got all of that, and we've got condo processors, which are, again, for the circuit 4s. We've got carbon nanotubules for more circuit 3s, and space science and utility science here at the nano electromechanical systems. So it's used in a lot of stuff. Like, not joking. Your silver is used for a lot of stuff. Specifically, your silver zinc alloy is used for a lot of stuff. So something tells me that going into the late game, your silver is going to be pretty much dumped into silver zinc alloy to get a lot of the more high-tech things. And the actual silver itself isn't going to be used for too awfully much. Now, this ethylene chlorohydrin is used in ethylene glycol. So if you're doing ground boring, you're also going to be using quite a bit of, well, I'm not going to say quite a bit because it is actually a very low amount overall, but you are going to be using a non-zero amount of your silver for doing ground boring of anything that needs drilling fluid 2 and drilling fluid 3 at that point. Otherwise, there's just lots of stuff here, like intelligent units. Yeah, it all feeds into this circuit 3, circuit 2, or not 2, circuit 3, circuit 4 process as time goes on. So, with that, will conclude today's overview of the lead chain. Just bearing in mind here at the beginning of this video that I did make a very slight mistake in that, two slight mistakes actually, in that there is a geometric series here feeding back into G1, and that Refined Dust 3 goes into Solution 1 and not Pulp 1. That's just because the icons are very similar between the Pulp and Solution. So, your Dust 3 into Solution, your Pulp 1 goes into Solution 1, and then combined they continue into your Concentrate, into your High Grade. And then the High Grade gets reduced and then sintered. With that, I would like to thank you all for watching. This has been Otaku Showboat. Don't forget to comment, like, subscribe, and hit the notification bell to help keep this series higher in search results. You can follow me on my Twitch page at twitch.com/otakushowboat. Follow me on Twitter at otakushowboat, and visit my website at otakushowboat.com. You can help fund my continued existence, as well as the increased rate of production of these tutorial series, by becoming a patron on Patreon at patreon.com/otakushowboat. You can also help support the continued development of these mods at patreon.com/Pyanodon. The next tutorial, as I've stated, is the chromium and gold processing tutorial, where there will essentially be 2 chains in one video, because gold is a chain in and of itself at Purple Science, so look forward to that one. And after that, we're doing circuits. After that will be circuits, and then green science, and then we get to move on to all of the remaining ore processing chains as we lead into the various individual steps that will eventually culminate in Circuit 2s. I hope to see you all then.